Hello. And welcome to another fantastic, awesome, out of this world, so many adjectives could describe it, but I'd run out of time, edition of Philip's Podcast, or P. How you like them apples? Today's podcast is going to be on lesson 6.4, simplifying square roots. Our target or goal for you today is when you're done watching this podcast, you should be able to add and subtract square roots as well as simplify square roots. Some vocabulary words in today's podcast: volume, how much you can put inside a shape or item. Volume refers to three-dimensional objects, and the unit for volume is always cubic. The product property of square roots. Well, the word product means to multiply, so we're going to talk about the product property of square roots later, and product means multiply. Like terms. Been doing it all the way since August of last year, chapter 1, but who's keeping track? Obviously I am. Like terms, hearts and stars, combining like terms. Perfect squares. In math, we talked about numbers that are called perfect squares, such as, just some examples, there's many. The square root of 9. We say the square root of 9 is a perfect square because when you punch it in your calculator, you get a whole number, counting number, or natural number of 3. There is no decimal. Perfect squares. Minus 10 bears. There we go. The square root of 144, another perfect square. Why? When you punch it in the calculator, you do not get a decimal. Perfect squares. Radical sign. In math, another term for the square root is the radical sign. I promise you, there's really one more. I told you, you just had to be patient. Just like I've been patient for a Cubs World Series for 103 years, but who's counting? The quotient property of square roots. Quotient means to divide. The quotient property of square roots, quotient means to divide. Let's take a look at some examples. The directions say simplify 5 square roots of 2 plus 4 square roots of 2. Well, first thing I'm going to do is I'm going to look at my square root symbols, and I'm going to look at the radicand. Nice vocabulary, plus 10 bears. And the radicand is the number that's under the square root. Both of them are 2, so these are like terms, or you can think of them as hearts or stars. So I'm going to give both of them a heart because they're both the square root of 2. The directions tell me to simplify, so I'm going to add my coefficients. Nice vocabulary, plus 10 bears. I'm going to add my coefficients. So I have 5 plus 4, which gives me 9. Both of these are the square root of 2, so they are like terms. So I'm just going to bring my square root symbol down, and 2. Bada bing, bada boom, there is my answer. 9 square roots of 2. Now, if the problem was different, let's say I had 5 square roots of 2 plus 4 square root of 3. I'm going to look at my radicand. 1 is a 2, 1 is a 3. Those are not like terms. We should remember, if they're not like terms, we cannot combine them. So you can think of this as a heart and this as a star. Since these are not like terms, I cannot combine them. That is my answer. So remember, guys, when you're asked to simplify with square roots, if it has an addition sign, you're going to add the coefficients, and if the square roots are the same, keep them the same. So I added the coefficients, that gave me 9. The square roots are the same, I kept the square root the same. Okay, let's take a look at a problem with subtraction. Like terms, they are both the square root of 3. So I can give both of them hearts. The problem asks me to subtract. I'm going to subtract my coefficients. So I have 2 minus 7. 2 minus 7 gives me a negative 5. Now, I just take my square root, which is the square root of 3. They're like terms. And I just tack it on at the end. Or you can think the dog follows you wherever you go. Woof, woof. If I change the problem, 2 square roots of 3 minus 7 square roots of 6. Are these like terms? Excellent job. Plus 10 for your group. They are not like terms. So we should remember, if they're not like terms, you cannot combine them. One's a heart, one's a star. Since these are not like terms, I cannot simplify it anymore. This would be my answer. So when I'm asked to subtract with square roots, subtract the coefficients, subtract the coefficients. If the square roots are the same, keep them the same. If the square roots are the same, keep them the same. All right, let's take a look at one more example before we go to the next page. Are they like terms? Excellent job, they are. Plus 10 for your group. They are like terms. They are both the square root of 7. Now, you should remember that there's an imaginary 1. So I'm going to stick an imaginary 1 here. I'm going to subtract my coefficients. So I have 2 minus 1. Once your square root is the same, keep it the same. So my answer to this problem would be 1 square root of 7, or, excellent job, plus 10 for your group. The other way you could write the answer is just square root of 7, because that 1 is really imaginary. In this problem, they asked me to simplify the square root. So I have the square root of 50. When I'm simplifying square roots that are just standing by themselves, there's no adding, there's no subtraction, I'm going to try to break the square root down into perfect squares. So this is what Mr. Phillips means. Think of a factor tree. 2 numbers that you can multiply together to get 50. I'm going to think 25 times 2. That gives me 50. But since I'm talking about the square root, radical sign, I'm going to give 25 a radical sign and 2 a radical sign. Now I'm looking for perfect squares. You should be able to see that 25 is a perfect square. The square root, the square root of 25 is 5. 2 is not a perfect square, so I cannot simplify this anymore. So my dog follows me wherever I go. There's your answer to the problem. 5 square roots of 2. So take the square root when it's standing by itself, try to break it down by finding perfect squares. So I asked myself, what numbers can I multiply together to get 50? I could do 1 times 50, but 1 and 50 are not perfect squares. 2 times 25. 25 is a perfect square. The square root of 25 is 5. I cannot break down 2 anymore. It is not a perfect square, so I just make them touching because it was multiplication. 5 square roots of 2. So you could have said 1 times 50, 2 times 25, 5 times 10. But remember, I'm looking for perfect squares. There's my perfect square, 25. So that's why I use 25 and 2. It doesn't do me any good to use 1 times 50 and 5 times 10 because they are not perfect squares. Plus 10 for your group. All right, let's try another one. Simplify the square root of 98. I'm going to think of all the ways I can multiply to get 98. Well, I can do 1 times 98. 98 is an even number, so I can multiply 2 by something to get 98. I know that 2 times 49 is 98. I'm not going to go any farther because I know right now 49 is a perfect square. So I can multiply 2 times 49 to get 98. And remember, this is a set of factors I'm going to use. Why? Because 49 is a perfect square. I have to give both of them a radical sign. So I have the square root of 2 times the square root of 49. 49 is a perfect square. That gives me 7. I cannot break down the square root of 2. It is not a perfect square. So my dog follows me, woof, woof, wherever I go. So the solution to this problem would be 7 square root of 2. If I went back to the example before I just did, this was multiplication. One of the vocabulary words for this lesson was product of minus 10 bears. Product property of square roots. This is called the product property of square roots. And remember, we said earlier that the word product means multiplication. So if you want to earn 10 in Mr. Phillips' class, anytime we use this, remember the product property of square roots. Product means multiplication. Now I'm going to cut and paste this and throw it onto this slide, because instead of using the product property of square roots, division, excellent job if you said another word for division is quotient. So this time, since I'm dividing, this is going to be the quotient property of square roots. Dividing, quotient property of square roots. They asked me to simplify this. I'm going to rewrite the problem. Square root of 11 over the square root of 16. Well, remember, in our last example, we were always looking for perfect squares. Look for perfect squares right here. I have a perfect square. The square root of 16 is 4. 11 is an irrational number, plus 10 bears. You cannot break 11 down any farther by the square root because you get a decimal. It's not a perfect square. So since it's not a perfect square, I'm going to leave it the square root of 11. I cannot simplify anymore. This is my answer, the square root of 11 over 4. So when you're dividing, give both of them a radical sign. Look for perfect squares. 16 is a perfect square. The square root of 16 is 4. This is not a perfect square. It's an irrational number. Since it's not a perfect square, an irrational number, just leave it the square root of 11. Volume. They asked me to find the volume of this rectangular prism. Remember, by definition, volume is the length times the width times the height. Well, since we have FCAT 2.0 now, they no longer use this formula, length times width times height, because that's old school. They use a new formula, which is the volume is the base times the height. Now remember, on the FCAT 2.0, when they use volume equals the base times the height, they get the base as the product of the area of its base. So what they do is they do square root of 5 times square root of 10 to get their base. Or the other way I've seen it written on the FCAT 2.0 is volume equals BWH. This is the one that I'm going to use because I'm used to using length times width times height. Just multiply the three numbers is what I'm going to do. So I have the square root of 5 times the square root of 10 times the square root of 2. And remember, I'm trying to find the volume, so I'm going to multiply the three sides together. Well, I'm going to ignore my square roots for now, and I'm going to say 5 times 10 is 50. So now I have the square root of 50 times the square root of 2. I'm going to ignore my square root signs for now, and I'm just going to do 50 times 2. 50 times 2 is 100. Now I'm going to put my square root. I'm always looking for, excellent job, plus 10, perfect squares. 100 is a perfect square, so the square root of 100 is 10. My unit is meters, and since I'm talking about volume, my unit is always cubed. And if you didn't know the formula to find the volume of a rectangular prism, it's listed right on your handy-dandy reference sheet. All right, a couple more problems, and then I promise you I will pause the podcast because Bulls versus Hawks Game 6 on TNT tonight, 8 p.m., but who's keeping track? All right, guys, I'm asked to simplify this expression. First thing I'm going to ask myself, do I have like terms? Yes, I do have like terms, so I'll either give them both stars or both hearts. I'm asked to add the, excellent job, plus 10 for your group, add the coefficients. 2 plus 4 gives me 6. Both of them are the square root of 3. Once they are the same, keep them the same. My answer to this problem would be 6 square roots of 3. Once your square roots are the same, keep them the same. I have like terms. Either give them both stars or give them both hearts. First thing I'm going to do is add my coefficients. So I have 7 over 8 plus 3 over 8. I have a common denominator, so I don't have to change either of my fractions. 7 plus 3 gives me 10. Speaking of 10, minus 10 bears. Ay caramba. There we go. Maybe not. Holy cow, are you keeping track of how many minus 10s I've gotten? There we go. 7 plus 3 gives me 10. Once your denominator is the same, keep it the same. Once your denominator is the same, keep it the same. You should be able to see that 2 is your greatest common factor, plus 10 bears. I'm on my way to getting back to my positive yardage. 10 divided by 2 gives me 5. 8 divided by 2 gives me 4. So I have 5/4, and the dog follows me everywhere I go. Once your square root is the same, keep it the same. So I have 5 over 4 square root of 11. Do not say 11 and 11 is 22. Epic fail, like the Boston Celtics last night against the Miami Heat in Game 5. Come on, guys. The other way you could write this answer, 5/4 can be written as a mixed number as 1 1/4. There's my dog, woof, woof, that follows me wherever I go. My square roots are the same, so I'm going to give them both hearts or both stars. Excellent job, because you said, Mr. Phillips, there's an imaginary coefficient of 1 here. I'm going to subtract 1 minus 4. 1 minus 4 is going to give me negative 3. Once my square root is the same, keep it the same. So the solution to this problem, when I simplify it, would be negative 3 square root of 6. Both of my square roots are the same, so I'm going to give them both hearts or both stars. Yeah, it's a cub-like star. No comments. I'm adding. I'm going to do 3/4 plus 5/4. Both of my denominators are the same, so I'm going to keep them the same. 3 plus 5 gives me 8. Once my denominator is the same, keep it the same, I get 8/4. Excellent job. If you said you can simplify that, you can divide both of them by 4, which would be the greatest common factor, plus 10 bears. Am I back to positive yards yet? 8 divided by 4 gives me 2, or you could say 2/1. Another plus 10 bears. Once my square root's the same, I'm going to keep it the same. So here's my answer, 2 square roots of 5. Next example. I have a square root of 2 here, but I do not have a square root of 2 over here. Therefore, they are not like terms. Since they are not like terms, I cannot combine them. If there was a square root of 2 here, then I could. But this does not have a square root of 2. So I'm just going to say my answer is a square root of 2 plus 1. My denominator is 9. My denominator is 9. You cannot combine them. They're trying to trick you. The other way you could write the answer, you could say the square root of 2 plus 1. And since both of your denominators are 9, you can just write 1 fraction bar and write 1 9. Because what this really means is the square root of 2 over 9 plus 1 over 9. These are equivalent. This is just the lazy man's way, because you only have to write the 9 once instead of writing it twice. All right, last slide. Bulls, Hawks, Game 6, TNT tonight. Go Bulls, baby! First thing I'm going to do is I'm going to try to break this down and find a perfect square. So I can do 2 times 9 to give me 18. So really this is the square root of 2 times the square root of 9. I'm always looking for perfect squares. The square root of 9, 3. I cannot break down the square root of 2. It's an irrational number. The dog follows me wherever I go. My solution would be 3 square roots of 2. The square root of 48. I can multiply 1 times 48, 2 times 24, 3 times 16, 4 times 12. Well, I have a couple choices here. 16 is a perfect square, and so is 4. I'm going to use 3 times 16. So I have 3 times 16 gives me 48. It's really the square root of 3 times the square root of 16. I'm always looking for perfect squares. Perfect square, square root of 16 is 4. I cannot break down the square root of 3 because that is an imperfect square. That's an irrational number. So the solution to this problem would be 4 square roots of 3. I'm going to use the quotient property of square roots. Plus 10 bears. Quotient means divide. So I have the square root of 17 over the square root of 49. I'm always looking for perfect squares. The square root of 49 would be 7. Irrational number cannot break down 17. It's not a perfect square. So my solution would be the square root of 17 over 7. And minus 10 bears. I guess it was a little sloppy, huh? All right, believe there's one more. More fun in the sun. The square root of 23 over 64. Quotient property of square roots. See, I got my 10 back. Square root of 23 over the square root of 64. Perfect square. Square root of 64. 8. Irrational number. Plus 10 bears. I got to be in the pluses, the positives right now. I can't be in the negatives. Can't break down the square root of 23. It's not a perfect square. There's my solution. Square root of 23 over 8. All right. I told you. I was wrapping it up. Bulls, Hawks. Go D-Rose. Hoped this podcast helped you on lesson 6.4. Stay tuned for our next podcast on lesson 6.5. More fun in the sun with the Pythagorean theorem. See ya. Wouldn't want to be you. Go Chicago.